In this video, we're going to explore the binomial distribution. We're going to Excel to calculate probabilities associated with the binomial distribution, and then we're going to perform a series of experiments and try to confirm the results of the probability calculations with those experiments. So for my illustration, I'm going to use a binomial experiment where the probability of success in each trial is 25%. So under the probability P, I'm going to put 0.25. And that we're going to do 10 trials. Okay, so N equals 10. And X is going to be the number of successes out of those 10 trials. So the possible values of X range all the way from 0 to 10. So let's put those possible values in a column. And now what I want to do in the column next to that, labeled P of X, is to calculate the associated probability for each one of those possible outcomes. You have a formula in your textbook that calculates these probabilities, but that formula is built into Excel, and it looks like this. Just that when I put the left parenthesis, it prompts me for the appropriate inputs, the first of which is the number of successes. Now, I'm entering the formula on the row corresponding to no successes, but instead of typing 0, I'm going to click on that cell, because when I copy the formula down, I want X to change for the other rows. Second input, it wants the number of trials, so I'll put 10, and the probability for success each time, 0.25, and then this last argument is supposed to be false for our application. We don't need to talk about that's the case. But notice I get a probability between 5 and 6%, which is small and is to be expected, given that, we're talking about no successes in 10 trials when we had a 1 in 4 chance of success each time. That's not very likely. And now I'm going to copy this formula down. The reason you see that it is not changing is that I have set my worksheet to force me to recalculate everything that I do by pressing the F9 button. Let me pause for a minute and show you how I did that, because that actually becomes a nice thing later on, as you'll see. So under File, Options, Formulas, it's normally set to automatic, but I have set it to manual. Okay. All right. So the next thing I want to do is perform a series of experiments, a lot of experiments actually, have the computer just randomly do these trials over and over and over again and record the percentage of times that I get various numbers of successes and put those results in this column labeled %X and see how they compare to the predicted probabilities. So to begin with, we would like to do just one experiment, 10 trials, and we're going to have the computer do the experiment for us by having it generate a random number for each trial, and we'll consider that trial to be successful if that random number is less than 0.25. So the following generates a random number between 0 and 1. And we'll copy that all the way over to do 10 trials. And I got to hit the F9 button to get them to regenerate. And now the question for this experiment is how many of these, how many successes do we have? How many of these numbers are less than 0.25? And we can use the counting command in that last entry here to determine that. So we'll highlight that range of numbers. And then less than 0.25. So I use a quote, a less than 0.25, quote, hit enter. One of those numbers, and we'll go back and look, that appears to be correct. success in 10 trials. Okay, now, do is repeat this 100 times and then look at the distribution as percentages, the distribution of each of the possible successes in each experiment. So to do it 100 times, I'm just going to copy that row. Oops, went way too far. Down to here, hit F9, and now that right-hand column is the number of successes in each one of those 100 experiments. And what I want to know is how that breaks down percentage-wise. What percent of those are zeros, what percent are ones, and so on, and put the results in this column under %x. So to do that, then I'm going to use the counting command. And I want to know how many of those numbers are 0 or the number x. So I'm just going to click on that cell. Now if I just hit return now, 3. Okay. But I want to know that as a percentage. So how many experiments did I do? 100. So I'm going to divide that number by 100. So that's 3%. Okay. Now, before I copy this down, there is one issue that happens when you copy it down. The range reference is going to change. It's going to shift down automatically, and I want to prevent that. So I'm going to put a dollar symbol next to the M's. That'll keep these cell references from changing when I copy the formula. So I'll copy that down, and now you'll see, oops, got to hit F9 again. Now you see the percentage of zeros, ones, twos, threes, fours, fives, sixes, sevens, and as it turns out, there were no times when there were 8 successes, 9, or 10, which is not surprising at all. Those are all very unlikely outcomes. So, and there was only one of 6 or 7. But this is where we've been trying to get to. We wanted to compare the results of an experiment to predicted probabilities. And notice that they're pretty close. Like 25% is the predicted proportion of outcomes of 3 successes, and 21 is what actually happened. Over here, they're not very close. 5% versus 9%. We can easily do the 100 experiments again simply by pressing F9. Everything changes, right? But they still seem to be staying pretty close to the predictions. So another way to compare them, though, is to graph them, and that may be an even better way to illustrate. So we'll highlight these 2 columns and go to Insert, Recommended Charts, and Line Chart. And now this graph is showing us in blue the predicted proportions from the probability formula, and in red the actual outcome of our 100 experiments. And again, if we want to just watch how the results change by repeating the 100 experiments, we can press F9 again and again and see sometimes they're very close, sometimes they're not so close, because each of these 100 experiments is random, right? So what's the next thing we could do to even more reinforce the value of these probability formulas? Well, we did 100 experiments. That's not really all that many. What if we did, instead of 100, what if we did 1,000? We did 1,000 experiments. We might expect that the probabilities and the outcomes of the experiments would be a lot closer. So in order to accomplish that, let's go down to the bottom and let's just extend by copying experiments way down to right there. So now we have 1,000 experiments instead of 100. I'm going to hit F9 again. change our formula here. So we need to make the cell reference go all the way down to 1,117, and we need to divide, instead of dividing by 100, divide by 1,000 to get the appropriate percentages. And now we'll copy that down and hit F9. We still did not get any occurrences of 8, 9, or 10. I guess, again, that's not terribly surprising. I bet if we do this experiment a few times, we'll see that change. But look how close in the graph the results are to the predicted probabilities. Let's hit F9 a few times and see how that changes. It's changing, but more often than not, it's staying closer than it did with only 100 experiments, right? On this last one, I got 1 out of 1,000 occurrences where there were 8 successes in a trial. Very unlikely, but possible, right? So this is an experimental illustration of the binomial distribution and the associated probabilities. And that concludes this video. Try it yourself.